Hello and welcome to Advanced Mathematics 1, Unit 5, Part 5, Factoring Completely. So basically we're just going to be adding some additional tools onto our factoring repertoire today. By the end of this lesson, you'll be able to do the following things. Factor the difference of two squares. We'll get to that in a little bit. Factor perfect square trinomials. Nice thing about that one is technically if you don't remember the pattern, you can just use split middle term. Factor polynomials by grouping. This will be situations where you have a 4-term polynomial and the only way to factor it is by grouping. And then finally, factoring polynomials completely. This will involve noticing other patterns. Instead of like an x times an x, you might have an x squared times an x squared in your factors. And so that's going to create different looking factoring than what we've been doing so far. So that's what we're talking about there. The main concepts for today are as follows. First is factoring a difference of two perfect squares. So I have one number that's a perfect square minus another number that's a perfect square, then it's going to factor as a plus b times a minus b, because that's what causes that middle term to drop out, is the positive and the negative of the same term. The second is for perfect square trinomials. Again, if you don't see the pattern, you can factor it by split middle terms. So like this one, it's not a huge deal if you don't remember it. But if you see this pattern and you recognize it, it just speeds things up for you. So a squared plus 2ab plus b squared. So you have a perfect square and a perfect square. When you take their square roots and double that, you get the middle term. Then you end up with a plus b quantity squared as your two factors. Same thing with a negative in the middle, then it's a minus b quantity squared. And that's basically just something you can memorize to speed it up for you. Again, use split middle term if you can't recognize the pattern. On our first example, we have a binomial. So I'm going to look and see if this is a difference of perfect squares. So I look at the first term, is 64 a perfect square? Yes, it is. 64 is 8 squared. So I'm going to write what that is. And the x is obviously x. X times x is x squared. And then 81 is also a perfect square. It's 9 squared. So I just rewrite it like that so I know what the two factors are. So they're going to be these two numbers with a plus and a minus in between them. So 8x minus 9, and then 8x plus 9. It doesn't matter what order you do it in. It could be plus then minus, minus then plus. As long as one is plus and one is minus, because that's what causes that middle term to drop out. So this one is just a matter of recognizing that pattern. Okay, example 2, we know we're dealing with a perfect square trinomial, so I'm going to show you how this works if you're trying to recognize that pattern. So I'm looking at the first term and I'm saying, is that a perfect square? It is. Is the last term a perfect square? Yes, it is. So if this is a perfect square trinomial, then this middle term has to be double the product of this. So 2x times 3 is 6x. Double that is 12x. Since it's minus, there's going to be a minus in the middle. So I'm going to do 2x minus 3, and the quantity is squared. And that's all there is to it. So like I said, it's a lot faster if you recognize the pattern, but if not, you can do split middle term. It will still work out the same way. All right, for example 3, we have 4 terms. So that means we have to do factoring by grouping. Now this is not an exact science. You may have to rearrange it before you can factor it by grouping. But basically what you want to do is you want to split it in half and look at the first half and the back half and see if there's anything in common. So looking at this first half, there would just be an x in common. and I'd be left with a 3x squared plus 2. I look at the back half. I'm trying to get this 3x squared plus 2, so I'm thinking -4. Does that work? Let's see. 4 times 3x squared makes 12x squared, so that works. Once you get that first one, you can just see if it factors out of the second one. If not, rearrange the terms and try again. And then -4 into -8 is +2. So that did work out. So my factors are x minus 4 and 3x squared plus 2. Now you always want to look at your factors that you get out of factoring and grouping and see if any of the two factors have a common factor within it. Neither one of these do, so I'm at my final answer. If there was something in common in one of the two terms, then I would factor it out of that term. All right, moving on to example 4. Example 4, we can see it has stuff in common. So we're going to start by factoring out the GCF. So this has more letters in it than you're used to seeing, but that's okay. You just have to look at it and say, okay, what do I do first? I look for a GCF. So 4, 4, and 80 are all divisible by 4. All three terms have a b in them, so I'm going to take out a b. And then the lowest value of the x is just x to the first. So I'm going to pull that out front. So what am I left with? Out of this first term, the 4 and the b cancel. I'm left with an x squared. Out of the second term, the 4 goes out, but leaves a -1. The b goes out, and I'm left with an x. And then my 80 divided by 4 is 20. It'd be negative because the 80 is negative. And the b and the x both are gone. Now, I'm not done. This is a trinomial, so I want to factor that. It's a normal trinomial with a first term of 1. So I'm looking for things that multiply to 20 that subtract to 1. So 21 do not. 10 and 2 do not. 4 and 5 do. So in order to make a negative middle term, the bigger one has to be negative and the smaller one has to be positive. So that 4bx is still out front. And my two factors are x minus 5 and x plus 4. So that was just a normal problem where you had to take out a GCF first and before factoring it. All right, in our last example, you can see all three terms definitely have a common factor. So that's always where we start. I said push the button, please. So the common factor of all the numbers is a 3, and all the letters is an x squared. So we're going to pull that out of everything to start with. When I take a 3x squared out of an x to the 8th, the 3's cancel, and I'm left with x to the 6th, because you subtract the exponents. And then the second term, I have 15 divided by 3 is 5. X to the 5th divided by x squared is x to the 3rd. And then 18x squared divided by 3x squared is going to be 6. And that is that. Now, you might think you're done, but this is still a trinomial, and x to the 6 is double 3. So if you see a power on the x that is double what's in the middle, the power in the middle, then that can still factor. The two factors are just going to be x to the 3rd and x to the 3rd rather than x and x. So this is the new pattern that you want to look for, is when the exponent is double the middle one. So I'm still going to factor this exactly the same as I would if it was an x squared term. I look at the end term, it's a 6. It has a first term of 1, so I can just do normally factoring. So I'm looking for two things that multiply to 6 that add to 5. They're both going to be positive. So 6 and 1 do not, but 3 and 2 do. So those are my two factors. So I have 3x squared, but both are going to be x to the thirds in here. And I have a plus 3 and a plus 2. So that's all there is to that. Just recognizing that that first term has double the exponent of the middle term. I will see you next time. Goodbye.